everybody. Welcome to the last unit of the year. Unit 12 is on similarity. I know this topic has come up briefly. I know when we talk about congruent triangles, usually this comes up as a point of discussion as well. But for today, we're actually going to take a little pause and do an algebra review on proportional reasoning. Okay, some vocab quickly first, and then just one or two practice problems with you before I have you just try a few on your own. I'm confident you remember how to do this, but let's do a quick review just in case. So some vocab to start. Two terms we're going to look at: ratio and then proportion. Oftentimes they get confused or interchanged with one another when they're not exactly the same. So a ratio basically is a fraction, right? So it's an expression that just compares two quantities using division. And I'm going to underline expression. We'll get to kind of the opposite of that in proportion in a minute. Not opposite, but the other term I'm thinking of. So this is an expression that compares two quantities using division. Okay, so for example, it might look as a fraction, written as a fraction, a to b, a divided by b, a over b, whatever you'd like to say. You might write it this way: a to to b, or a colon b. You would still read that as a to b. You see that a lot when you're talking about odds and gambling. That notation is used. Now, so that's a ratio, just a single fraction. I said I was going to underline that, so there we go. A proportion is basically two ratios set equal to each other. Okay, so it's an equation where you're equating two ratios. I'm going to write it this way. So it is a statement of equality. You need an equal sign in there between two ratios. Okay, so for example, 6 over 18 equals 1/3. That's technically a proportion. You're not solving for anything there. That is a proportion. We'll see something more like this: 6 over 18 equals 1 over x, and we'll be asked to solve for x. Okay, so that's the big difference, the kind of key takeaway from this. Ratio, a single fraction; proportion, two fractions equal to each other. Okay, so let's look at an example where we'll need to set up some proportions and then solve for that x that we saw. Okay, example A. In a photograph, Dan is 2.5 inches tall and his sister Emma is 1.5 inches tall. Dan's actual height is 70 inches. What is Emma's actual height? So I'd actually like you to think about starting this on your own first. In a second, I'll tell you to pause, but I want you to write down a proportion that you would use to solve this. Now, some of us might be tempted to just kind of go to the calculator right away and come up with an answer, and likely you would be correct, but I want you to kind of force yourself to write out a proportion that represents this information. Okay, so go ahead and pause and do that on your own, and then come back to me and I'll share some with you. Okay, so here's what I had initially. This is kind of where my head went initially. So I did 1.5 to 2.5 equals x over 70. Now, do not panic if you don't have that. There are literally 8 different proportions you could write for this particular problem. Okay, so the kind of the easiest change is just to take the reciprocals. Maybe you had 2.5 over 1.5 and then equals 70 over x. Now, what I'm using here, here's my thought process. This left-hand side represents the picture height. Right, so if I'm comparing picture height, and this would be Emma to Dan. That's important, that I have Emma on the top and Dan on the bottom. The right-hand side then represents their actual height. Still in that same order though. Emma is my unknown one, she's x, so Emma's on the top, Dan is on the bottom. Okay, so that's one proportion you could have. You could also have, let's kind of rearrange things here a little bit. 2.5 to 70, think about what that represents, equals 1.5 to x, 1.5 over x. You'll hear me saying 2 a lot, so just don't get thrown off by that. Now, if I'm going to set it up this way, I'm talking about Dan's measurements here in both examples, but on the top it's the picture height, and on the bottom it's real life. Okay, on the right hand side then, I kind of need the same setup here. I got Emma represented on the right hand side. This is her picture height over her real life height. So notice kind of the comparison between the two sides. Now you could, again, take reciprocals of that as well. So that you could see gives you 4 proportions, and then the other 4 really are just flip-flopping what you have on the right and left-hand sides. So don't panic if I'm writing a proportion down throughout this unit and yours looks totally different than mine. That is a-okay. We're going to get the same answer at the end. Now let me take, actually it doesn't matter which one here. I'm going to take this one, and if we think about solving a proportion, we're going to try to be, I will probably try to be consistent throughout this unit in how we solve. Sometimes there are easier ways to do this, but let me just be consistent here. We're going to cross multiply. Okay, so let me remind you how to do that. You sort of multiply diagonally here. Let me rewrite this one. 1.5 to 2.5. So do me a favor, if you didn't write this ratio, you can put this one in your notes. So we're going to cross multiply here. So I'm going to multiply kind of diagonally here and diagonally here. So from this product, I get 2.5x equals 1.5 times 70 is 105. Divide both sides by 2.5. X equals 42. And let's remember what that is. That is Emma's height in real life. Okay, so Emma's 42 inches tall. Now, one thing I'd like you to think about is, so yes, I'm always going to ask you to set up, a proportion, but I think it's just as helpful to think about, we're just going to say a bad ratio that would not work. Because some of these are obviously going to get a little more complicated than this. So here's what I mean by a bad ratio. Let's say if I did 1.5 to 70. Let's pause. Let me go back up here and see why that would not be helpful. So I'm comparing Emma's picture height to Dan's actual height. There are too many variables flying around in there, right? So if I said that equals 2.5 over x, because now I've got Dan's picture height to Emma's actual height, right? Too many things flip-flopping here. So this is a bad proportion. Oops, I used the wrong vocab word there. Set up a bad proportion. Okay, let me think of another bad one here. Let's see if we did x I guess this is the same thing. X to 2.5 equals 70 over 1.5. Right, I just have the reciprocals and kind of flip-flop. So this is still Emma in real life, Dan in the picture. I don't want them on the same side. Dan in real life, Emma in the picture. Too many things jumbled around there. Okay. Another thing I want to note, in case you solve this problem right off the bat, and you solved it by different method than cross multiplication. Let me just go back up off to the side here. This is just a little note. Nothing you need to do with this, but just something to notice. So let's say I had, let me maybe use this one instead. 70 to 2.5 equals x over 1.5, because this might be tempting to solve this a little bit differently. If I take this 70 over 2.5 and actually divide that, I get 28 equals x over 1.5. And then you would multiply both sides by 1.5. Okay, what this is saying, this 28 here, and this sort of gets lost in this cross multiplication step. That number never really shows up. But this is telling us that real life is 28 times bigger than the picture. Right, that's what this kind of left-hand side ratio could tell us. If you're comparing Dan's real height to the picture height, it's 28 times bigger. So then we would just take Emma's real height and multiply by 28. That's what this step is doing. So that didn't necessarily show up in your work, and that's okay, but I just want to point that out because you might see this 28 is significant, even though it sort of gets lost in the cross multiplication step. Okay, let me do one more just strictly algebraic example with you. We're going to solve this proportion. Go ahead and take a second and copy that down. Pause it if you need to. Okay, and we will do the same step every time. If you know there are often algebraic steps you could do a little bit differently. I'm going to just be consistent with cross multiplication. Now be careful this time. So we're going to multiply diagonally here. So we've got 10 times that whole quantity, 3x minus 13. Notice I'm putting parentheses around that. That is necessary. That equals 23 times this whole quantity, x plus 40. Okay, so we just have a little bit of distributing to do. I got 30x minus 130 on the left-hand side, and 23x plus, that's 920 on the right-hand side. Let's get all of our x's together. I'm going to subtract 23x from both sides. I'm going to add 130 to both sides, and then finally divide by 7. Okay, so just a little bit trickier algebraically. Okay, I would like you to try some practice problems on your own for me. I will have the answer key posted on the Google Classroom. Please try them on your own first before you look at that answer key. We're going to do page 579, 1 to 17, just the odd problems. And then I will post, it's a answer key. It has a little more on there than you need. It has the even ones as well. You can just ignore those, check the odd ones. And as always, shoot me an email if you have questions. I'm happy to do a Google Meet with you. Okay, get those problems done. I will talk to you tomorrow. Bye, guys.